Some number 174. A uniform rope 172. A uniform rope of length L resting on frictionless horizontal table is pulled at one end by force F. What is tension in the rope at distance L from the end where the force is applied? Okay. At distance L from where force is applied, what is the tension? Force is applied from right end. We want to find what is force acting at distance L from one end. Force is F at this end distance L. At that end we are interested in what is the tension on the string. See, had it been here what is tension, what you will say? Hello?
So where?
At the extreme end, what would be the tension?
Friction.
No, there is no friction. This is F. F. Tension is F. F
The
will.
normal.
Ah. So what is total mass of the string? Can I tell mass per unit length is m by L?
Yes, sir.
So this will have how much mass?
Into smaller. M by L into smaller.
Into small L, yes. So since we want tension the rope at this L, that means indirectly it is that reaction away from here.
Yes, sir.
So this is action, means this is your reaction. So on this end, tension at this end is moving away. So I should find what is net normal reaction here. That is, if I get this N, these two are same to same.
Yes, sir.
Entire body will move with acceleration, total mass into total A. So acceleration is F by A. So if you consider this part, then this is tension here. This is
Yes,
nothing
sir.
but, yeah, that is nothing but N equals to its mass into acceleration. And on right side it is pulled by F. So F minus, see this is the body, this is the normal reaction. If I consider this body, then this is action and this is reaction. So on first body, N F minus N will be the tension because we want on the first body. N is nothing but Ma and F. So this is mass per unit length into L upon F by M, correct? Cancel. F common. 1 minus L by L is tension. F minus 1 by L is option D. Once again, you all see. Again, see concept is what? Hello? हाँ हाँ उसका जेरोक्स भेजा नहीं आपने जो बोला है भेजा अच्छा पर वही है क्या सब बराबर लाइन से अच्छा ठीक है देखता हूँ टाइम मिलेगा तो मैं आता हूँ नहीं तो मेरे हिसाब से एडजस्ट करूँ हाँ हाँ ठीक है ठीक है बताता हूँ लेक्चर के बाद बताता हूँ once again see understand the concept first. This is that rope. At distance L we want tension. That means this is moving away. This is that N. If this is N means here it is F. So net tension will be F and N ka difference. Now this is normal reaction. Okay.
Yes, sir.
And normal reaction, if you consider this body, this is total length is L and this is L. So its mass is this part I am talking about. Huh? So mass of this part on which this action is acting will be M equals to total mass upon total length into length L ka mass will become ml by L. Now net tension acting here will be T equals to right hand side force F minus this normal reaction N. F minus normal reaction is nothing but I have taken F larger because this is the force going to pull it. So this is nothing but this mass A ये हो गया ना इसका रिएक्शन वाला पार्ट mass into acceleration. So F minus M mass into acceleration is net force upon net mass. So therefore F common if I take minus इधर ही आ गया small m is m by L into F by M. This will get cancelled. So if you take F common, 1 minus L by L is the required tension. Followed?
Yes, sir.
See, this is the force pulling it, but there will be reaction. So ये दोनों का difference will be net tension acting here because this is opposing. So it is trying to cancelling that. So therefore net tension acting is difference of these two. F forward and backward. Now solve further. Yes, Aryan, any doubt?
No, sir.
Done, sir.
Then which sum?
173.
173. One 173. A large mass, very good sum this also 173. See, these are, if difficult question comes, then this will come in the exam. Looking at this type paper, we wonder whether these things they will ask or not, but we can't take risk. This is block of mass m. A large mass m and mass small m are hanging at the two end of the string that passes through smooth tube as shown in the figure. Small m moves in a circular path to the tube. Small m moves in a circular path. Okay, circular path making length n inclined at angle theta. The length of the string from mass m to the top is L. Theta is the angle string makes with vertical. What is necessary frequency nu of the rotation of mass so that mass remains stationary. See, this mass will remain stationary only if इसका centrifugal force और ये mg बैलेंस करना चाहिए ना. हेलो,
Yes, sir.
सर्कुलर मोशन कर रहा है मतलब इस पे सेंट्रीफ्यूगल फोर्स आएगा ना, ऐसा आउटवर्ड. ये आउटवर्ड थ्रो हो गया तो ऊपर जाएगा, बट इसका वेट इसको बैलेंस किया तो ना ऊपर जाएगा ना नीचे जाएगा. सो मास कैपिटल M will remain stationary if mass capital M will remain stationary if weight of mass capital M balances centrifugal force on small m. So capital M ka mass weight is mg and that is m omega square r. If this is r, what is this radius? Can you tell? This is length L. So what will be this radius of rotation? Hello?
Yes, sir.
No, I'm saying what will be this radius of rotation of horizontal circle, because this length is given L and then it is performing circle. So this is like L sin theta. No?
हाँ.
तो ये कोनिकल पेंडुलम हो गया ना अपना ये वाला पार्ट,
हाँ.
जिसका टाइम पीरियड मालूम है मतलब ओमेगा मालूम है, बराबर, और फ्रीक्वेंसी मालूम पड़ गया. चलो इतना लिख लो पहला, फिर मैं आगे इसको सिंप्लीफाई करता हूँ. सिंपल लॉजिक है, वेट इज बैलेंस्ड बाय सेंट्रीफ्यूगल फोर्स, बस. और वो सेंट्रीफ्यूगल फोर्स का रेडियस L नहीं है, इट इज बिहेविंग लाइक कोनिकल पेंडुलम, जिसका टाइम पीरियड वी नो 2 पाई रूट ऑफ L cos थीटा अपॉन G.
Done, sir.
Okay, till that you have done, na?
Yes, sir.
Done, sir.
एक सेकंड करता हूँ. So this becomes mg equals to m into 2 pi by t the whole square into r. Therefore mg is m into 2 pi 4 pi square. एक मिनट, फ्रीक्वेंसी चाहिए ना, तो इसको मैं 2 पाई ओमेगा लिख देता हूँ, 2 पाई न्यू. 2 pi nu the whole square into r. Therefore mg equals to m into 4 pi square nu square into r. So nu square equals to mg upon 4 pi square small m into r. So nu equals to 1 upon 2 pi root of mg upon small m into r. 1 upon 2 pi root of capital mg upon capital mg प्रिंटेड है बराबर into r. एक मिनट, 175. So capital mg upon m into r r is L sin theta. So there is printing error on 173 we are doing. एक उधर देखो दोनों स्मॉल एम कर दिया है बी ऑप्शन में. सो कैपिटल एम जी एम आर एंगल इज स्मॉल देन आर कैन बी टेकन एज एल, ऐसा उनका बोलना है.
Yes, sir.
Moves in a circular path of radius r. Length of the string makes angle m at the top is L. So length of string they have taken as r everywhere, assuming that r is very small. Theta is very small. So this is the answer. ये किधर है? B में है.
Done, sir.
Now till 177, any doubt is there?
175.
175. Consider the situation shown in the figure. The acceleration of the block of mass m will be how much? Acceleration of the block of mass m will be how much? 175. Block of mass m. This is pulley. This pulley is movable. Here it is fixed. So this is 2m. What is acceleration of the block m? G by 3 up, G by 3 down, G by 2 up. Okay. This is mass 2m, acceleration of the block. See that last lecture also I had explained. This is t, correct? इसका इधर t,
Yes, sir.
इसका इधर t हो जाएगा बराबर.
हाँ.
सेम स्ट्रिंग इसलिए ऐसा हो गया. अभी खाली आपको इतना याद रखने का है, इसका जब ये एक्सेलरेशन a होएगा या इसका a, तो इसका स्ट्रिंग मैंने बताया था ना 2 बार लूज होएगा. मतलब ये अगर ऊपर हुआ x ये वाला साइड, तो इधर x, तो ये 2x से मूव होएगा ना, बिकॉज इट इज
हाँ तो 2a हो जाएगा.
मूवेबल पुली है ना, ये मूवेबल पुली. सो इफ दिस इज a, दिस इज a, ये 2a हो जाएगा. ये क्लियर हुआ? या इसको a लिया तो a by 2 हो जाएगा. गॉट इट?
Yes, sir.
Yes, sir.
वापस देखो, ये पुली ऊपर गया बाय डिस्टेंस x, तो ये इधर से x, इधर से x, तो ये 2x आगे आएगा ना, तो इसका एक्सेलरेशन डबल हो जाएगा. सो आई एम राइटिंग दिस एक्सेलरेशन एज 2a, दिस एक्सेलरेशन एज a. सो सिंपल नाउ. तो ये a से एक्सेलरेट हो गया, ये 2a. इतना आया क्लियर मीनिंग?
Yes, sir.
You have to find what is acceleration of this. Now if I consider this pulley, this is angle theta they are saying. Angle theta. So tension T, theta is given 30. Oh, good. हो गया फिर. इसको ये m g sin theta नीचे पुल करेगा. So can I say T minus capital mg into sin theta equals to its mass into 2a. Any doubt? First,
Yes, sir.
देखो ये नीचे बराबर, मतलब डाउनवर्ड फोर्स, बट बॉडी इज मूविंग. तो कौन सा ज्यादा है वो मालूम नहीं ना, ये टेंशन है, ये नीचे जाएगा, अच्छा नीचे ही जाने वाला है ये, तो mg sin थीटा आई शुड राइट, ये मास 2m ज्यादा है ना, तो ये नीचे आएगा कंपेयर टू दिस, और t up mg sin, this is pulling it downward, we don't know who is larger, so up the plane or down the plane we are not knowing. अगर निगेटिव आंसर आ गया तो उल्टा बोल देंगे, बस इतनी टेंशन। हेलो हेलो,
Yes, sir.
राइट नाउ
Yes, sir.
एज्यूमिंग कि नीचे आया, अगर आंसर निगेटिव आया तो आप अप द प्लेन मत बोलना, डाउन द प्लेन बोलना, एंड सो ऑन। सो दिस इज आवर फर्स्ट इक्वेशन, t minus mg into sin 30 is half equals to m into 2a, let this be equation 1. Now if you consider इसका free body diagram, then 2m downward into g, and I'm assuming that motion is in downward direction.
Yes, sir.
देखो ऐसा है ना, ये ऐसा जाके ऊपर गया, नीचे आया तो ये अपवर्ड होएगा, तो चलो एज्यूम कर, तो एज्यूम कुछ भी कर सकते हैं, 2mg डाउनवर्ड, इसका फ्री बॉडी डायग्राम, माइनस 2t अपवर्ड, है ना, ये दोनों का t इज इक्वल्स टू, उसका टोटल मास 2 है एंड एक्सेलरेशन इज a. Now if I substitute this t here or divide throughout by t, 2, ये दोनों तीनों कैंसिल हो जाएगा, इक्वेशन 2, नाउ ऐड किया तो ये t और ये माइनस t कैंसल, माइनस ऑफ 2 half of mg, this first free body diagram you followed.
Yes, sir.
Yes, sir.
Now I'm just adding this, so t minus t cancel, minus half plus 1 कितना, minus half plus half ना,
हाँ.
plus half mg is equals to m times 2a into ma, so 3ma, mm cancel, this is g by 6 equal to a हो गया, हेलो,
Yes, sir.
g by 6 equal to a आया ना, this is t minus mg half equals to ma, minus t plus t got cancelled, minus half plus half is plus half, 2 plus 3 ma, a is g by 3, so acceleration in that block will be how much, a is g, acceleration in the block is 2a, that means it is 2 times g by 6, g by 3 is the answer, check करो g by 3 है क्या आंसर, g by 3 is the answer, yes g by 3,
Sir, up the plane होगा.
नहीं नहीं डाउन द प्लेन ही आ रहा है ना, डाउन वाला ही हमने,
हाँ.
g by 3 अप द, हमको आंसर प्लस आया ना, तो अपना राइट आंसर,
हाँ.
g by 3 अप द प्लेन, आंसर क्या दिया है, सम नंबर क्या है, 175, हाँ ये दिया है बराबर, अप द प्लेन राइट है अपना आंसर। सी अगर माइनस आता ना तो डाउन द प्लेन कर देना, खाली इसमें एक ही इंपॉर्टेंट है, इफ पुली इज मूवेबल तो उसका अगर एक्सेलरेशन है तो फिक्स्ड वाले का 2 है, ये मैंने आपको पहले समझाया था कि अगर मैंने पुली को इमेजिन करो हाथ में पकड़ा और ऊपर पुश किया तो उसको दोनों साइड से धागा एक्स एक्स ऊपर जाएगा, तो जो फिक्स्ड वाला बॉडी है उसको 2x से पुल करना पड़ेगा ना आगे,
हाँ.
तो इसके वजह से आगे आंसर उसका एक्सेलरेशन 2। फिर से बताओ क्या समझ गया बराबर,
समझ गया.
देन 176 177
No, sir.
नो डाउट, 179
No doubt.
No, sir. 180.
180 के बाद ना वो थोड़ा डायग्राम से एक बार मैं फिर से चेक कर लेता हूँ, है सब राइट ही है, फिर भी एक बार चेक करके फिर करता हूँ, मैं थोड़ा थियरी कराता हूँ अभी आपको,
Okay.
हाँ बिकॉज Rest one. You could complete till 2 or 25.
Yes, sir.
Yes, sir.
एक मिनट पूरा कर ही देता हूँ, फिर सॉल्व चाहिए तो मैं सोच रहा था थोड़ा थियरी भी कर देता था। 224 यू गॉट द आंसर? फटाफट चेक कर लेते हैं। ओके, एक मिनट स्टॉप करता हूँ क्योंकि जो लेट ज्वाइन किया उनका हुआ नहीं है। टिल 1 to 50 आई टोल्ड टू रिवाइज जेनिफर एंड आर्यन सिंह। उधर तो कुछ डाउट है आपको?
यस सर।
डाउट है?
हाँ
फटाफट क्लियर कर लेता हूँ, फिर आगे जाता हूँ ताकि सबका हो जाएगा। चलो 1 to 10 एनी डाउट? बी क्विक।
सर, नाइन्थ वाला।
नाइन्थ
वो
वन,
लालन वाले पे हमने बहुत टाइम डाला था, तो वो वाला तू ले सकता है, बिजनेस वाला, बिजनेस स्पेसिफिक।
नाइन्थ वन यू वांट ना? ओके, नाइन्थ। A hammer 3 kg strikes the head so that drives 1 centimeter impulse. What is impulse? Force into time or change in momentum.
Change in momentum. Yes sir.
So change in momentum is mass into velocity here, because when it goes inside it will come to rest. So only one velocity. M is 3 into 2, 6 is the answer. Clear?
Yes sir.
It will be final velocity is 0, initial is 3, 2, but in magnitude it will become 6. Then after this which sum?
सर तो वो 1 सेंटीमीटर इनवर्ट गया, उसका कोई सिग्निफिकेंस नहीं है ना?
नहीं।
ओके।
हाँ से
Sir, 12.
हाँ, what you are saying?
12th question.
Where I have given 3:30 to 4:30. Today only we had spoken na? हाँ, that was today only. Today is Wednesday. Where it is written tomorrow? यार, I had discussed with you all and where I have written tomorrow? हाँ, because I had discussed with you all and you had told that today it is possible, and then you said it is not possible. Okay. No problem. No problem. Yes, yes. Okay, fine. Yes, sorry. After this, which one?
Sir, 12.
12th, okay. Ashleisha, can you explain 12th?
1 minute, sir.
Now, this time when you are able to tell the answer, तो 101% perfect हो जाएगा. Ayush, you can also try, and Ananya, you can also try. And if you know, please tell me how to solve.
Yes, sir.
Now, if you have done once now, तो ठीक हो जाना चाहिए. मुझे तो याद है 41% आंसर है. Aryan, read it. Read.
Sir, I've done, sir.
You have done this. Okay. You got 41%?
Yes, sir.
Okay, just read it. Let me see whether same method you have done. A stone is dropped from height h. No? A stone is dropped from height h. It hits the ground with certain momentum, that is p. If the same stone is dropped from height 100% more, that means 2h, then what will be the momentum? Changes by how much is the question.
Sir, V is root
V,
2GH.
हाँ.
हाँ बराबर. अब इधर से इधर हाइट आया तो वेलोसिटी इन फर्स्ट केस is root of 2gh by using formula v square equal to u square plus 2as and drop bodies का initial moment velocity. For second body 100% more मतलब its height is original plus 100% of original, which will become 2h. So it is 2g 2h. So momentum of first one upon momentum of second is mass into velocity, which is root of 2gh upon root of 2g 2h. 2g 2g you can cancel, hh you can cancel. We get p1 upon p2 is 1 upon root. Then p2 is root 2 times p1. Very important sum. Such type of things are frequently asked. Not very difficult will be asked, I feel this time. Now, if this is root 2, then percentage change, shortcut method, is this root 2 minus 1 into 100. This is our shortcut method. If new value, suppose R2 is new radius, becomes n times R1. Then n minus 1 into 100 is called percentage change. Why it is called so? Percentage change means change which is new minus original upon original into 100. So this is n times R1 minus R1 upon R1 into 100. R1 common will get cancelled. You will get n minus 1 into 100 is called as percentage change. So if the body is dropped from height h, momentum p, when height is double h, then percentage change in momentum will be how much? So first wala velocity was root 2gh, second wala root 2 times 2h. So I got p2 is root 2 times p1. So this will become 1.414 minus 1 into 100. That is nothing but 41.4%, which we can write as 41%. This is the required answer. After this, which sum?
Sir, 37.
Okay. 37. 1. Aslesha, Ananya, and Ayush. You all know 37?
Yes, sir.
Because if once done, after 3-4 days also you should be able to recollect it. You are saying yes, then it is very good. It's 12th I am clearing, okay? Jennifer, can I clear 12?
Yes, sir.
37th. A bullet emerges from a barrel which is 1.2 meter long with speed of 640 meter per second. Assuming that the approximate time spent in the barrel gun will be how much? V square is u square plus 2s. Bullet is initially at rest plus 2a. It travels distance 1.2 when it emerges out. So we can say v square upon 2.4 equal to a. Now A is v minus u upon t. जानबूझ के वैल्यू नहीं डाला, एंड में डालता हूं. So acceleration you got v square upon 2.4. This is v minus 0 upon time we have to calculate. So v square upon 2.4 is v by t. V I can cancel. So from this t equals to 2.4 upon v, which is 640. 6 into 424. 16. 6 into no 8 3s are 24. 0.3. 8 8s are 64. So this is 3 into 10 raised to minus 1. 8 into 10 raised to plus 1. That is 3 by 8 into 10 raised to minus 2, which you can write as 30 upon 8 into 10 raised to minus 3 second, which is 4 millisecond. This answer, 4 millisecond.
Yes, sir. Done.
Now till 50. Till 50 with some.
Nothing, sir.
So now I'm starting. Please now complete till at least 100, so that you all catch with the other students also slowly. So next class I will discuss till 100 if any doubt is there. Now I'm doing one
Okay, sir.
new concept I'm doing. Conservative force and non-conservative force. Conservative force and non-conservative force. Now as you see, non-conservative मतलब फिर से मिल जाना चाहिए. Non-conservative मतलब वेस्ट हो जाता है. जैसे फ्रिक्शन होता है non-conservative. But ideally speaking, conservative forces are those forces in which work done does not depends upon path. कंजर्व एकदम अच्छे से कर लो, ये थियोरेटिकल क्वेश्चन में आपको मार्क जा सकता है. कंजर्वेटिव फोर्स, फर्स्ट पॉइंट, इन दिस फोर्स वर्क डन बाय सच फोर्स इज नॉट डिपेंडेंट ऑन पाथ. एग्जांपल बताता हूं आपको. नॉट डिपेंडेंट ऑन पाथ. लाइक सपोज I take the body from A to height B. Same body, I take it from A to B, then B to C. What is work done in first case? M, G, H or not? No?
Yes, sir.
In second case, what will be work done?
MGH only.
MGH only. That means whether I go straight or I go A to B and B to C, my answer is remaining same. So I say that force is conservative force, independent of the path. In thermodynamics, you will study internal energy is independent of path. So here it depends only on initial and final position. If starting ending remains same, then answer will remain, force will be conservative. One more example, you see. I go from A to B directly. My work done is W1. If I go A to B, work done is W2. If I go from A to C, work done is W3. So can I say W1 is same as W2 is same as W3?
Yes, sir.
Because net displacement is same, na? So W1 is W2 equals to W3. So the force was conservative. If work done is same, this is the meaning. So theoretical questions you can get off this type. Just write this theory.
Done, sir.
Examples of conservative forces are gravitational force is conservative. Spring force, which is F equal to minus kx, is conservative. Electrostatic force is conservative. Suppose I take a body block of mass m. I'm just checking a gravitational force is conservative or not. If I take this block m from A to C directly, in second case I take it from A to B and then B to C. I want to check that gravitational force mg, whether it is conservative force or not. Length of, suppose this inclined height is L. So definitely this will become L sine theta. For path 1, what will be work done for first path? Force into displacement into cos theta. Correct?
Yes, sir.
Force is mg, displacement is L, and what is angle between F and S? F is downward, S is here L. This is angle total. Can I say it is 90 plus theta?
Yes.
Yes, sir.
So that will become mg L. Sin 90 plus theta, cos 90 plus theta is minus sin theta. That means it is minus mg L sin theta if it is taken from A to C path 1. Now for second path, let us check what will happen. That means I took A to B and then B to C. So initial and final position I have kept same, path I have changed. So for path 2, work done for path 2 is work done to move A to B plus work done to move B to C. What is work done to move A to B? Can you tell? Force and displacement are at 90 degree, na? So 0,
0. Yeah.
because it is mg, ये displacement s का बीच का एंगल 90 है ना, cos 90, ये एंगल 90 है, बराबर ना?
Yes, sir.
Work done along, this is mg, displacement is a to b, that means it is L cos theta, displacement and angle between mg and this displacement is 90, so cos 90, मतलब ये डायरेक्टली ये मिलके 0 हो गया, प्लस वर्क डन अलोंग BC is nothing but minus of mg, minus because force is acting downward, into L sin theta. So can I say final answer will be mg L sin theta? So what we can see, for A to C or A to B and then to C, if initial final position remains same, work done is constant. So I can say gravitational force is conservative force. What it meaning?
Yes, sir.
Yes, sir.
Just copy. Build your concept stronger than any type of sums you can do.
Done, sir.
Everybody is done?
Yes.
Now suppose we have closed path. Then see what does it mean. Work done by conservative force in a closed path is always zero. So if I start from A, go to B, to C, to D, to E, and back to A, then work done is zero. Work done by conservative force in a closed path is always zero. See why it is like that. You can see if this is positive, तो इसका उल्टा इधर नेगेटिव हो जाएगा, कैंसिल हो जाएगा. तो सेम वे ये डाउनवर्ड ये अपवर्ड मिलके कैंसिल हो जाएगा. So work done around closed path is always zero. Hello?
Yes, sir.
Yes, sir.
But total work done is not always zero when displacement is zero, because friction की वजह से भी हो सकता है कभी कभी. तो कंजर्वेटिव फोर्स है तो उसकी वजह से ही जीरो होगा. But if they say there is friction, then I cannot say it is always zero, even though net displacement is zero. Here, so clearly we can see net displacement is zero. So one is that you can say zero, but just remember not always. Only for conservative it is zero. So total work done is not always zero. That I'm showing you how. When displacement is zero. Because we may get confused. तो ये closed path तो ऐसा भी हो गया ना, net displacement zero, therefore work done zero. But here net displacement is zero because forces are conservative. If there is some frictional force, तो wrong हो जाएगा answer. Please copy this much. So total work done is not always zero when displacement is zero. Generally we write work done is zero when displacement is zero. Can I clear? Then I'm explaining how that work done is not zero when displacement is zero.
Yes, sir.
Suppose this is a block of mass m at point A. You take it up to point B. Displacement is S. Same block from B, I am bringing it back to A. Again, displacement is S. Where is friction acting? If the body is moving like this, A to B,
Opposite direction.
opposite means it will be here frictional force. So work done going A to B due to friction will be minus force into displacement. Now where will be the friction when I take B to A? Again opposite.
Yes.
Yes, sir.
So work done when body is taken B to A is again minus force into displacement. So total work done will be equals to work done from A to B plus work done from B to A. Both are minus Fs minus Fs. So can I say it is minus 2Fs, which is not equal to 0. That means work done by frictional force for closed path is not 0. Correct ना? Closed path मतलब net displacement 0. जिधर से गया उधर ही वापस आ गया तो closed हो गया ना.
Yes, sir.
So thus friction is non-conservative force. Just copy till this and below write thus friction is not conservative force. So that point remember in MCQ if they ask total work done by conservative force can be 0. But by non-conservative force in closed path not necessary when displacement is 0 it is. Thus friction is non-conservative force.
Done, sir.
So what is conservative force? Can you tell? Which does not depends upon path first point, and for closed path it is always 0. And non-conservative for closed path it is not 0 and it does not depends up here. It depends upon path, whereas in conservative it does not depends upon path. एक और एग्जांपल समझा देता हूँ. Non conservative force, it does not depends upon uh, it depends upon path that we are saying. So imagine this is one table with friction. Here we have a block A. I want to bring it to point B. एक तो ऐसा डायरेक्ट लेके आ सकता हूँ. Second, I take it to C and then to D and then bring it to B. मतलब ऐसे लेके गया. This is path 1 and this ACD is path 2. Now clearly you can see A to B का displacement is less as compared to A to C, C to D and D to B. That means
Yes, sir.
work done in first path is definitely not same as work done in second path क्योंकि हर एक का displacement अलग अलग है.
हाँ.
Also in closed path total 0 नहीं होगा तभी ऐसा possible है ना. अगर 1 और ACD दोनों सेम रहता, एक पॉजिटिव एक निगेटिव, तो 0 हो जाता ना आंसर. So in closed path work done is not equal to 0. So I got few points by which I can understand whether it is conservative force or not conservative force. ये समझ गया ना आपको क्या बोल रहा हूँ?
हाँ सर.
Yes, sir.
So conservative force and non-conservative force का distinguish. तो जनरली बुक्स में एकदम डिटेल दिया नहीं है, इसलिए प्लीज रिमेंबर प्रॉपरली. फर्स्ट path, second path, कोई भी path, it is independent of path. Here it depends upon path, so they are not equal for two different paths. That means here does not depends on path, does not depends upon path, depends on path. Third point, for closed path it is 0. And in non-conservative, for closed path not equal to 0. Now any theoretical, at least you can manage if they ask for conservative and non-conservative force. Just write example, this one, non-conservative force, why closed path it is not 0, then distinguish right up. Few more conditions are there how we can check conservative or not conservative.
Done, sir.
Those who have completed till all the sums of this work power energy, this one full, then I am just sending you the sheet of work power energy. I have given this work power energy ka sheet to you, PDF.
No, sir.
No, sir.
Okay. Or what is work, what is power, that I have explained you.
No, sir.
No, sir.
No, sir.
आज करने वाले.
आज बोला था वर्क और एनर्जी वाला.
हाँ.
यार याद दिलाना चाहिए.
मतलब ये वीक में.
अच्छा अच्छा ठीक है. तो 234 तक आपका पूरा सम हो गया ना. अभी उसके आगे वो शीट में सर्कुलर मोशन है, बराबर.
हाँ.
इन दैट कैन यू ट्राई एटलीस्ट 20 सम, 1 to 20, because tomorrow only we are meeting again. If any doubt is there, I can clear that. हेलो हेलो.
तो
Yes,
सर्कुलर का
sir.
अलग शीट है,
हाँ उसके आगे ही दिया है ना, वही जो पीडीएफ भेजा है उसके अंदर आगे है ना
उसमें
सर्कुलर.
225 तक है.
कितना?
हाँ फिर आंसर है.
हाँ फिर आंसर है.
कितना तक है उसमें बोल रहे हैं?
225.
अच्छा एक ही भेजा है.
हाँ.
नहीं मैं फोटो निकाल के भेज देता हूँ उसका भी. बट सर्कुलर का आई हैव ऑलरेडी सेंड यू ना वन शीट पहले.
हाँ सर.
So from that you do again 1 to 20.
ओके सर.
सर मेरे पास नहीं है.
वो मैं भेज देता हूँ आपको. एक मिनट.
क्योंकि हुआ ही नहीं है मेरा.
नहीं नो प्रॉब्लम नो प्रॉब्लम. एक मिनट आप टेंशन मत लो. आप लोग वर्क और एनर्जी का भेजता हूँ, उसमें से 10 करना, वो सबके लिए नया रहेगा. फिर 1 to 10, ओनली 1 to 10 यू विल ट्राई, नथिंग एल्स. और जमा तो ही आगे कर
ओके.
अभी, बिकॉज
Okay, sir.
वी आर डूइंग ऑन डेली बेसिस ना. नाउ टुमारो इज थर्सडे, अगेन सेम टाइम 12:30 we'll have class tomorrow. Now just see carefully. Those who have not attended law of motion from the start, for them target is today we discussed 1 to 50, correct? So for
Yes.
tomorrow I don't think till 100 you can manage. 51 I am telling 100, जितना आपसे हो सकता है उतना करना. ओके
ओके सर.
तो कल मैं क्या करूंगा, वर्क पावर एनर्जी का थियरी बताऊंगा और कंजर्वेटिव फोर्स और भी आगे समझाना है मुझे, so that no extra MCQs I am starting. So after discussion of this 51 to जितना भी आपका हुआ रहेगा, I will do theory of conservative and non-conservative. आगे बहुत थोड़ा लेंदी है ये, because this will come even in chapter called electrostatics, and then work power energy का theory. And other students from all starting उनको 1 to 10 ही खाली करना है. Of work power energy, the sheet I am sending after the class. Is that clear?
यस सर.
And
Yes, sir.
and Sunday's test will be on law of motion, not work power energy. 1 to 234 उसमें से I will ask you any 45 first. फिर उसके बाद मैं अननोन क्वेश्चंस देता हूं, पहले इसमें से ही देता हूं, देखता हूं आपको 180 में से 180 मिलता है क्या. See if you have done all sums, then practically you should get full.
Yes, sir.
But if it is selective, let us check that whether you are able to get 180, फिर next वाला different test paper देता हूँ. So that's all for today. Do well planned thing. Nothing is very difficult because paper easy आ रहा है, इससे danger है थोड़ा. So अगर वापस